Right now, as you are watching this video, a 1,300-pound NASA spacecraft is hurtling through Earth's atmosphere at thousands of miles per hour. It's on fire, it's uncontrolled, and nobody, not NASA, not the US Space Force, not a single scientist on this planet, can tell you exactly where the pieces will land. This is not science fiction. This is not a movie trailer. This is happening right now on March 10th, 2026, and it is the #1 trending story in America tonight. Stay with me, because over the next 15 minutes, I am going to walk you through every single update, hour by hour, from the moment this story broke. I'll tell you what this spacecraft really is, why it's falling years ahead of schedule, what NASA is not telling you up front, and why this particular satellite crashing to Earth matters more than you think. My name is your name. Let's get into it. Let's go back to August 30th, 2012. It's a warm Tuesday morning at Cape Canaveral, Florida. NASA is launching 2 spacecraft, twin probes, into one of the most dangerous regions of near-Earth space. These are the Van Allen probes, named after the legendary American physicist Dr. James Van Allen, who in the 1950s discovered something extraordinary. Earth has 2 massive invisible shields surrounding it, giant donut-shaped rings of high-energy charged particles, electrons and protons, trapped by Earth's magnetic field, extending from roughly 400 miles above our planet all the way out to 58,000 miles into space. We call them the Van Allen radiation belts. And while they might sound scary, they are actually Earth's natural force field, protecting us every single day from deadly solar radiation, cosmic ray bombardment, and the constant stream of charged particles blasting off the sun called the solar wind. Without these belts, life on Earth as we know it would be in serious trouble. Satellites would fry, power grids could go dark, GPS would stop working, communications would be disrupted, astronauts in orbit would face life-threatening radiation levels. So in 2012, NASA said we need to understand how these belts actually work. How do they gain and lose energy? How do they respond to solar storms? And can we use that knowledge to protect our technology and our astronauts better? That was the mission. 2 spacecraft, twin probes, Van Allen Probe A and Van Allen Probe B, built by the Johns Hopkins University Applied Physics Laboratory, launched together on a single rocket, sent into a highly elliptical orbit that cut right through both radiation belts. The plan was simple: a 2-year mission, gather data, come home, done. But here's where the story gets interesting. These probes were built for 2 years. They lasted nearly 7. Probe A continued operating until October 2019, Probe B until July 2019. 7 years of continuous data collection in one of the harshest radiation environments ever studied by a spacecraft. For context, these probes were flying through regions where most spacecraft and astronaut missions deliberately minimize exposure to avoid crippling radiation damage. These probes lived there, and in those 7 years, they made discoveries that rewrote textbooks. The biggest one was that NASA's Van Allen probes were the first ever to discover the existence of a 3rd Van Allen belt. That's right, we thought there were 2. There are actually 3. But the 3rd one is temporary. It appears during intense solar activity like a solar storm, and then fades away. Before the Van Allen probes, we had no idea it even existed. Scientists literally saw it appear and disappear in real-time data for the first time in history. The data from this mission is still being used today in 2026 to help scientists predict space weather, protect GPS satellites, keep astronaut missions like Artemis safe, and even understand potential threats to Earth's power grid during solar events. So these probes weren't just successful, they were transformational. And then in 2019, they ran out of fuel. They could no longer orient themselves toward the sun to generate power. Mission over. NASA's engineers did the math and said, don't worry, the satellites are in a stable orbit. Atmospheric drag will slowly pull them down. They won't re-enter Earth's atmosphere until around 2034. We have plenty of time. They were wrong. Here's something most people don't know. The sun is not constant. It breathes, it pulses, it has cycles. Every 11 years, the sun goes through what scientists call a solar cycle, swinging between periods of low activity, called solar minimum, and peak activity, called solar maximum. The solar cycle that was active when the Van Allen probes launched in 2012, solar cycle 24, was actually unusually quiet, weaker than average. So the atmosphere above Earth stayed relatively calm, and drag on orbiting satellites was lower than normal. But solar cycle 25, the one we're in now, is a completely different beast. In 2024, scientists confirmed that the sun had reached its solar maximum, the peak of solar cycle 25, and it hit harder than anyone predicted. The most powerful solar flares in years, massive coronal mass ejections, geomagnetic storms slamming into Earth's magnetic field, And here's the physics. When solar activity spikes, it superheats the upper atmosphere, the thermosphere and exosphere. The atmosphere literally expands outward, puffing up like a balloon. And when that happens, there are more atmospheric molecules at higher altitudes. More molecules mean more drag on anything orbiting in that zone. Van Allen probe's orbit started at an apogee of about 18,900 miles from Earth. The close approach, the perigee, was just 384 miles up. Every time the probe swung through that low point, it skimmed through a thicker than expected atmosphere, and every pass slowed it down just a tiny bit more. Month by month, year by year, the orbit shrank faster than anyone expected. By early 2026, scientists realize this satellite is coming home, not in 2034, now, this month, this week. Now let me walk you through exactly how this story has unfolded in the last 24 hours, because this is real-time breaking news and the updates have been coming in fast. 24 hours ago, Sunday, March 9th, 2026. On Sunday evening, NASA released an official statement on nasa.gov. The headline was, Van Allen Probe A to re-enter atmosphere. For the first time officially, NASA confirmed the uncontrolled re-entry was imminent. As of March 9th, the U.S. Space Force predicted the spacecraft would hit the atmosphere at approximately 7:45 p.m. Eastern Time on Tuesday, March 10th, 2026, with an uncertainty window of plus or minus 24 hours. Translation: sometime in a 48-hour window, possibly Tuesday evening, possibly Wednesday. A 1,123-pound spacecraft is going to barrel through Earth's atmosphere. NASA's statement said most of the spacecraft is expected to burn up as it travels through the atmosphere, but some components are expected to survive re-entry. And then the line everyone is quoting, the risk of harm coming to anyone on Earth is low, approximately 1 in 4,200. 16 hours ago, news organizations began reporting the story with headlines saying a 1,300-pound satellite was expected to re-enter Earth's atmosphere. People started asking where it would land, whether they could see it, and whether they should be worried. Meanwhile, space tracking sites were overwhelmed with traffic as thousands of people tracked the satellite's orbit in real time. Space debris experts began appearing on news programs explaining that objects have re-entered before with even higher probabilities of harm, and nothing happened. 8 hours later, another report revealed something interesting. NASA has internal standards for re-entry risk requiring a probability of harm to be no greater than 1 in 10,000. This satellite's risk was calculated at 1 in 4,200, more than twice the agency's own threshold. To address that, NASA issued a formal safety waiver for this re-entry. That doesn't mean NASA acted recklessly. The spacecraft was designed before today's stricter debris. Mitigation standards existed. The Van Allen probes launched in 2012, and the rules became tighter after that. These probes simply did not have enough fuel to maneuver to a safer disposal orbit. As of this moment on March 10-11, 2026, the satellite has been tracked continuously by the U.S. Space Force. The orbit has been decaying, and re-entry has been occurring around the predicted window. Most of the spacecraft, aluminum, titanium, electronics, solar panels, and instruments, burns up in the upper atmosphere in a blaze of superheated plasma, reaching temperatures of thousands of degrees. But some pieces will likely survive. Generally, the densest and most heat-resistant components survive re-entry. Things like titanium bolts, structural brackets, fuel tanks, and certain electronic housings. For a spacecraft weighing over 1,300 pounds, experts estimate a few pounds to perhaps a few dozen pounds of material might reach the ground. Most likely it lands in the ocean. About 70% of Earth's surface is water, and the orbital path lies within a narrow band near the equator covering huge stretches of ocean. However, space debris hitting land is not as rare as people think. Experts estimate that about once a week some object from space survives re-entry and reaches the ground. There have been multiple examples over the years. Debris landing in homes, washing up on beaches, or being discovered in remote areas. The only known person ever struck by falling space debris was Lottie Williams in 1997. A small piece of metal from a rocket stage hit her shoulder after she watched a fireball streak across the sky. She was not seriously injured, so when someone says the risk is low, they are correct statistically. But low risk is not zero risk. Here's why this story matters beyond the spectacle of a satellite crashing. As of 2026, there are roughly 27,000 tracked pieces of debris in Earth orbit. That only counts objects large enough to track. The number of smaller fragments is estimated at over 900,000. These objects travel up to 7,500 miles per hour. Even a marble-sized fragment can damage a spacecraft or puncture a station module. In the early days of spaceflight, satellites were simply launched, used, and eventually allowed to fall back to Earth. But the space industry has changed dramatically. Lower launch costs have allowed thousands of satellites to be deployed. Entire constellations now orbit the planet. The more objects placed in orbit, the more debris exists, and debris can create more debris through collisions, a chain reaction scientists call Kessler syndrome. Because of this, modern spacecraft are often designed to burn up completely during re-entry. But spacecraft designed more than a decade ago were built differently. Van Allen Probe A had a twin. Van Allen Probe B is still in orbit right now, and due to the same solar activity effects that accelerated Probe A's descent, Probe B is also expected to re-enter earlier than originally planned. Current estimates suggest it may return to Earth sometime before 2030. When it does, the same scenario will play out again. The Van Allen Probe A launched on August 30th, 2012. It was supposed to operate for 2 years. It operated for nearly 7. During that time, it flew through some of the most hostile radiation environments in near-Earth space, discovered a third radiation belt, and returned data that scientists are still studying today. Now, 14 years after launch and 6 years after its mission ended, it has returned to Earth. Not gently, but in a blaze across the atmosphere, burning away as it re-enters the planet it spent its life studying. Somewhere among the debris that may fall into the ocean or land on a remote piece of land could be a fragment that once orbited thousands of miles above the Earth, gathering data that changed our understanding of space. Space is complicated. Space debris is a real challenge. But the missions that created that debris helped humanity learn more about the universe around us. That is everything you need to know about the NASA Van Allen Probe A re-entry. If you found this video valuable and want more breaking space and science stories explained clearly and in depth, subscribe to the channel. Leave a comment and share where you were when you first heard about this story. Like the video if you learned something new and share it with someone who wants to understand the real story behind the headlines. I'm the Silver Index. Stay curious. I'll see you in the next one. This video is for educational and informational purposes only. All information is sourced from NASA, nasa.gov, US Space Force, CNN, ABC News, The Guardian, Space.com, and Ars Technica, dated March 9-11, 2026. This channel is not affiliated with NASA, the US Space Force, or any government agency. All statistics and data reflect official NASA and Space Force statements and are subject to update. This video does not intend to cause fear or panic. Space debris re-entry is a regular, monitored event. If you find space debris, do not touch it. Contact local emergency services immediately. No content in this video constitutes scientific, legal, or emergency advice.